All right, we're looking at trigonometry, finding side measures. Finding side measures of a triangle. Okay, first of all, we have to know our sine, cosine, and tangent. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent is opposite over adjacent. And the way I'm going to remember this, some old horse caught another horse taking oats away. That's the first letters here. Some old horse caught another horse taking oats away. So that's the way I remember this, but you may do it some other way. But anyway, we got to remember these trig ratios. All right, so what are we talking about here? All right, well, here's a first problem we'll look at. Find the measure of each side indicated. So here's my x. We want to find out what that side is. So here's the answer right here, by the way. Here's my angle, all right, that we're going to be using. So I need to label the sides according to that angle. Well, here's my right angle, so this is automatically the hypotenuse over here. And these two sides that form the right angle are the legs. One is opposite, one is adjacent. Well, for this angle over here, this is opposite. Down here's my adjacent. So they're all labeled. Now, when you label these sides, one of these doesn't matter to us. And if you notice in here, this adjacent side does not matter because there's no information down there. See, this side, the opposite, is 6. And this side we're looking for is the hypotenuse. So we're going to use the opposite and the hypotenuse in this one. All right, so if we go back to this right here, that's sine, opposite and hypotenuse. So we're going to do sine here. So I'm going to set this up this way. Sine of my angle, 56, equals the opposite, which is 6, over the hypotenuse, which is x. So that's how I set this problem up. Okay? Now, here's what you got to do then. When x is down here in the bottom, it's dividing. So you do 6 divided by sine 56. So I'm going to type in the calculator, 6 divided by sine 56. I'm going to type that in. Okay? So, I type that in, 6 divided by, and then see here's my sine button right here, sine. I just hit sine, and I'm going to type in there 56. And look at there, it's 7.2, which is what the answer was. Okay, so when your x is in the bottom, that's dividing. See, it's divided, 6 is divided by x. So to figure out what x is, I do 6 divided by sine 56. Okay, here's another one. And by the way, there's the answer for this one. All right, first thing we do is we label our sides according to my angle. Here's my angle right there, 17. All right, well, here's my right angle, which means this is automatically the hypotenuse right there. And then these two sides that form the right angle are my legs. One leg is opposite, which for this angle over here is opposite. And one leg is adjacent, which is right here next to it. So there's my sides labeled. Now, when I label these sides, one of these sides is unimportant in this problem, which is down here, hypotenuse. There's nothing there. So that side is unimportant. We're not even going to bother with it. We are concerned about the adjacent, which there's a 15 here, and we're concerned about the opposite, which is what we're trying to find. So the adjacent and the opposite, which, go back to our trig ratios, that's tangent. See, that's the only one that has adjacent and opposite. So this is a tangent problem. So I set it up this way, okay? Tangent of my angle, it's always sine, cosine, tangent of the angle, equals, and then you gotta have the opposite over the adjacent. So in this one, my opposite is x over the adjacent, which is 15. All right, now see x is on top, which means I'm multiplying. See, it's dividing in the bottom, on the top it multiplies. So I do 15 down here times tangent 17. So I'm going to do 15 times tangent 17. That's what I'm going to type in. All right, so 15 times tangent 17. 4.58, which we round to 4.6, and there's my answer right there. Okay. We're going to do 10 of these. That's number 2. Here's number 3. Okay. Find the missing side x there. Well, here's my answer right there, 7.6. Okay, but how do you do it? Well, there's my angle. And now label the sides according to that angle. Well, here's my right angle, which means way down here, this is the hypotenuse. And the two sides that form that right angle are my legs. One is opposite and one is adjacent. So for my angle here, over here is opposite, and right next to it, adjacent. And there's my sides labeled. Okay? Now, one of these we're not concerned about at all. Well, it looks like I'm concerned about this one because there's a 6.9. Right here, there's x. I'm concerned about that. There's nothing here. I don't care nothing at all about the opposite in this problem. So I'm concerned about the hypotenuse and the adjacent. All right, that's cosine. Hypotenuse and the adjacent. So the cosine adjacent over the hypotenuse. So this is going to be a cosine problem, which means cosine of my angle 25 equals, and again, cosine is adjacent on top, hypotenuse on the bottom. So my adjacent is 6.9 on top, and then x on the bottom. You got to get these in the right places, because if you don't, you'll divide instead of multiplying, or multiply instead of divide. So now in this problem, as we said a while ago, x is on the bottom, which means we divide. So I do 6.9 divide by cosine 25. That's how I type it in. It's always this number, whatever this number is over here, divided by the cosine, or this number times the cosine if it's on the bottom, you know, whatever. But you always put this number first, and then you cosine, tangent, sine, whatever. So let's see here, typing this in. Okay, I'm going to do 6.9 divide by cosine 25. And I get 7.6. There's my answer, see? All right, number 4 here. Find the missing side here. There's the answer, 4.3. But the first thing we always do is label my sides. So there's my right angle, which means over here, this is the hypotenuse. Which I can tell already the hypotenuse is, we're not concerned about it because there's nothing there. We're not concerned about that. There's my angle I'm going to deal with, which makes this opposite. And right next to it's my adjacent. So there's my sides labeled. All right, as I've already mentioned, we're not concerned at all about the hypotenuse in this problem because there's nothing there. We're concerned about the opposite and the adjacent, which is tan again. Tan 43 equals the opposite, which is 4, over the adjacent, which is x. All right, and now since x is in the bottom, that means divide. See, this is divided by the x. So I'm going to do 4 divided by tan 43. All right, so 4 divided by tan 43. And that's 4.3. The 8 makes the 2 go up to 3. 4.3. There you go. Okay. Number 5 here. Label the sides. So here's my right angle, which means this is the hypotenuse. Here's my angle I'm dealing with, which means over here is the opposite, and right next to it's adjacent. There's my sides labeled. Okay, so label my sides. Now, which one are we not concerned about? Well, it looks like the opposite here. There's nothing there, so we don't care nothing about the opposite in this problem. We care about the adjacent because that's the side we're looking for, and we care about the hypotenuse because there's a 15 right there. So that's the two we care about in this problem. So it's adjacent and hypotenuse, which looks like cosine, adjacent hypotenuse. So I set this up this way. Cosine of my angle, 34, equals the adjacent x over the hypotenuse, 15. And since x is on top, that means multiply. 15 times cosine 34. Oops. So that's what I'm going to type in. 15 times cosine 34. And look there, I get 12.4. 12.4. Okay. Number 6 here, we're halfway on these problems. Then we'll have some other problems. There's my right angle, which means down here is my hypotenuse. There's my angle I'm going to deal with, which means over there is the opposite. And right next to it's my adjacent. Okay, there's the sides labeled. Well, now one of these we don't care nothing about, which in this problem looks like a hypotenuse. There's nothing down here. see I got an X here and I got a 6 there. So that's the two I'm concerned about. So adjacent, opposite, this is tangent. Okay, right there, tangent is opposite over adjacent. Opposite over adjacent. So I'm gonna do tangent 27 equals the opposite 6 over the adjacent X. And X is in the bottom, which means I divide. So I'm gonna set it up like this. 6 divided by 10, 27. All right, type it in there. 6 divided by 10, 27. 11.77, which is 11.8. There you go, 11.8. 4 more of these, and we're going to do some real life problems. All right, label the sides. There's my right angle, which means here's my hypotenuse. There's the angle I'm going to deal with, which means over here is the opposite. And right next to it's my adjacent. Now, which one do we not care about here? Which one do we not care about? Adjacent. I got an X here, and I got a 15 there. Don't have nothing there, so I don't care nothing about the adjacent. This is opposite and hypotenuse. And opposite and hypotenuse is sine. So this is sine of my angle 30 equals the opposite, X, over the hypotenuse, 15. That's how we set it up. X is on top, which means I do 15 times sine 30. Okay, so type that in, 15 times sine 30. 7.5, look there, got it. Okay, number 8 here. Label the sides. There's my right angle, which means down here is my hypotenuse. The two legs form the right angle. So for this one, here's the opposite leg, and then there's one next to it, adjacent. Now, which one do we not care about here? Well, this time's hypotenuse. We don't care about the hypotenuse. We care about this because there's a 13. We care about that because there's an X. So this is opposite and adjacent, which again is tangent. So to set this one up, this is going to be tangent of my angle 42 equals the opposite 13 over the adjacent X. X is in the bottom, which means divide. I do 13 divided by tangent 42. Okay. So 13 divided by tangent 42. And it looks like 14.4. Look there, we got her. 2 more of these, and then we're going to have some word problems, real life problems. All right, let's label the sides. Here's my right angle, which means there's my hypotenuse right there, and it looks like we don't care about it because there's nothing there. Now here's my angle I'm going to deal with, which means down here's my opposite, and right here's my adjacent. So there's my sides labeled. Now, which one do we not care about? Right there, the hypotenuse. Like I said, there's the X here, and there's a 15 there. So those are the 2 I care about, which is opposite and adjacent, which is tan. This is going to be tan 54 equals the opposite X over the adjacent 15, and the X is on top, which means I multiply 15 times tan 54. So 15 times tan 54. 20.6. There you go. All right, and then number 10. All right, label the sides. All right, let's see here. Here's my right angle, which means down here's my hypotenuse. You got to get these things labeled, right, or you're going to screw up. There's the angle I'm going to deal with, which means over here's my opposite. And it looks like this one's the one we're not concerned about. And then right next to my angle is my adjacent. So yeah, the one we don't care nothing about here is the opposite this time. We don't care anything about the opposite. There's an X here and there's a 4.4 there. So those are the 2 we're going to use. Which means adjacent and hypotenuse is cosine. We're going to do cosine. All right, so this is cosine of the angle 22 equals the adjacent X over the hypotenuse 4.4. And since x is in the top, that means we multiply. 4.4 times cosine 22. That's what I type in. All right, so 4.4 times cosine 22, yep. 4.07, which means 4.1. Rounds to 4.1. See, the 7 makes the 0 go up to a 1. Okay. Now, let's look at some real-life problems, okay? Let's see here. Okay. Now, in this problem here, a plane is at an altitude of 14,000 feet when it starts to descend to the runway at an angle of 12 degrees. Find the plane's distance to the runway. So like the distance from the ground, from here to here, the runway, this is the distance we're looking for. Okay? Now, it says it starts to descend at an angle of 12 degrees. So like here would be level. So it's descending at 12 degrees, which means this angle right here is 12 degrees. All right, well, when you have parallel lines like this and a transversal, see if this is 12 degrees, this is 12 degrees. This is from geometry, a transversal. These are alternate interior angles. So since that's 12, we know this is 12. Okay. Now label the sides of the triangle. So since that's 12, here's my right angle, here's my hypotenuse, and then this angle 12 means over here is my opposite, and then this will be my adjacent. So there's my sides labeled. Which one do we not care about in this problem? The hypotenuse. There's nothing there. We don't care about him. There's a 14,000 there, and there's a D there. So those are the two we care about, which is tangent. So to set this up, tangent 12 equals the opposite, 14,000, divided by the adjacent, which is D. Okay, and since that's on the bottom, we're going to divide 14,000 divided by tan 12. All right, so type this in here, 14,000 divided by tan 12. That comes up to 65864. 65864. That's how many feet from the runway they are. And see, these planes, they have to calculate this stuff. They have to have this calculated to precise a measurement because, you know, they got to hit this runway squared off. If they don't, if they hit it short, they're going to crash. And if they hit it too far long, you know, here's the runway. If they hit it way down here somewhere instead of hitting it there, then they could run off the runway at the end. So this has to be calculated, man, and that's what they do. They calculate these angles for these, you know, using this trigonometry. Here's another plane. Okay, in this problem here, a plane just took off from the runway. Oh, get it on here no better. Plane took off from the runway at a 28-degree angle of elevation. If the plane's altitude is 2,500 meters, how far has the plane traveled from the runway? Around to the nearest meter. So you see X right here is what we're looking for. So there's a picture. There's a picture of the whole thing right there. So we can go ahead and label our sides. So here's my right angle, which means this is my hypotenuse up here. For this angle, over here is the opposite, which means this side's adjacent. Now, which of the three sides do we not care about? This one down here. There ain't nothing at the adjacent. We don't care about it. Hypotenuse is X. The opposite is 2,500. So this is opposite and hypotenuse. This is sine. So sine of 28 equals the opposite, 2,500, over the hypotenuse, which is X. And since X is on the bottom, we divide. 2,500 divided by sine 28. So 2,500 divided by sine 28. And this will get 53.25. That's how far the plane has traveled. Okay. All right, here's one I really like, the Eiffel Tower. person standing 100 feet from the Eiffel Tower. The angle of elevation from the person to the top of the tower is 84.6. Find the height of the Eiffel Tower. So you can see right here, here's this person. The angle of elevation that this person has to look up is 84.6. So that's this angle right here. He's standing 100 feet away from it. What's this measurement right here? So let me just draw it over again, okay? So here's my triangle. This is 100. This right here is 84.6. This is what we're trying to figure out right there. That's a right angle. Okay, so label the sides. Well, if that's the right angle right there, this is my hypotenuse over here. Which means for this angle, over here is opposite, and this would be adjacent. Now, which of the three do we not care about? Hypotenuse. We don't care nothing about that. There's a y here, there's 100 there. So this is a tangent, opposite and adjacent. Tangent of my angle, 84.6, equals the opposite, which is y, over the adjacent, which is 100. And now, since y is on top, we multiply 100 times tan 84.6. So 100 times tan 84.6. And that is 1057.88. And that's how tall the Eiffel Tower is. Okay. Now, one last problem, and this is it. The length of a tree's shadow is 20 feet when the angle of elevation to the sun is 40 degrees. That should be a degree thing. How tall is the tree around the nearest foot? Okay, so you can see the picture here. Let's redraw the triangle. This is 40 degrees right here. This is a right angle right there. This is 20 feet right there, so I'm going to put a 20 right there. We're going to figure out how tall this is. So there's my triangle drawn over, okay? Now label the sides. Well, here's my right angle, which means my hypotenuse is right here. For this angle, over here is opposite. This is right next to it, adjacent. Now, which of these three sides do we not care about? Right there, man, the hypotenuse. We don't care nothing about him in this problem. There's my opposite, which is a y, and there's my adjacent, which is a 20. All right, so this is tan. Tan of the angle 40 equals the opposite y over the adjacent, which is 20. So that's how it sets up. And since y is on the top, we multiply 20 times tan 40. 20 times tan, tan 40. And there you go, 16.78 or 16.8. So there's how tall the tree is. This tree, 16.8 feet. Which it's good to be able to do this because, like, if you're going to timber some trees down and you're looking at trees, and is this going to be tall enough tree to timber? You know, and these guys do these calculations. Anyway, that's trigonometry, finding side measures. So hopefully this helps you. If you need more help, though, just contact me anytime. Have a good rest of the day.